you have to think about the big picture. The big picture is not just about your landscape today.
Welcome to Shielded, the last line of cyber defense by PQ Shield, the podcast where we are moving the conversation around post-quantum cryptography from the why to the how. I'm Joe Lintzen, your host, and I'm here to guide you through the challenges, innovations, and solutions that will help your organization stay secure in the quantum era. Let's future-proof your defenses together. Today, we're joined by Cassie Crossley, Vice President of Supply Chain Security at Schneider Electric. Cassie is a recognized expert in software and hardware supply chain security, and her extensive work in securing critical infrastructure makes her an invaluable resource for understanding the unique challenges we face, especially as we enter the quantum era. In this episode, we'll explore the lessons learned from years of crypto agility efforts, the complexities of migrating supply chains in operational technology, or OT for short, and the ongoing work required to secure devices that have been and will be in the field for decades. We will also touch on the future of supply chain security and the critical role of cryptography in securing those OT systems. Cassie, thank you so much for joining us on Shielded, the last line of cyber defense.
Thank you so much for having me.
Absolutely, it's my pleasure. Now, Cassie, I know you're somewhat of a dog person, and I know you've spent a little bit of time last week at RSA conference. So, of course, the main question is: did you get a chance to see the puppies?
I did not. There were puppies?
They were puppies.
I missed it. I've heard about other conferences having puppies and adoption things. So no, I missed it.
They had actual puppies in one of the booths in the South Hall, and there was also one with goats. So if you want to go into farming, I guess you can go to RSA and get the lowdown.
Excellent. When I talk about supply chains, I show pictures of cows and how to make, cookies with cows, chickens, and, being, up the supply chain. So I like farm animals.
There you go. Perfect. And then, of course, speaking of RSA, you've had a session, I believe, on the risk of third-party vendor risk in hardware supply chains. So
yeah, I presented on hardware bill of materials. That was really interesting. We had a good crowd.
So maybe you can share a little bit about that for anyone who missed it. Like, what were the key points that you touched on and shared with the community at RSA?
Sure. Well, a lot of it was to get to the point of a call to action, which is we really need a community and to really move forward on hardware bill of materials, both as a standard, but also how to share them and move them along. Because I receive requests from our customers, including U.S. government, on hardware bill of materials, which include country of origin, and there's not a general standard to follow. CISA has as part of its ICT SCRIM, which is the Supply Chain Risk Management Task Force, they've created a document, but it never went further than that. And so I've been a part of the SBOM community for over 5 years. It's been around longer than that. And so having a community to really bring up to speed, the difficulties with hardware bill of materials is most folks in cyber are not really working on the hardware side unless they're a semiconductor or a physical manufacturer of products, which we do software, cloud, but also a lot of operational technology and industrial IoT products. So hardware, its origin, the linkage to drivers and SDK, software development kits, all of that is really important from a supply chain risk standpoint, not just libraries, commercial or open source. And so we were talking about the similarities and differences to software bill of materials and why this is an important challenge in regards to the provenance. Where do things come from? And so that was what the session was about.
So really building that bridge over and repeating and adjusting the work that has been done in the software bill of material working groups and transporting that into a hardware bill of material as well.
Yeah.
And of course we're also talking about the CBOM, right? That's right. Cryptography bill of material. So there's all three combined are certainly going to need to work in tandem to give us a better protection of the supply chain. So thanks for sharing that. And I guess besides that, sticking with RSA for a little bit, I know every year there's a lot of, exciting things happening at RSA. To me, it seemed to be there was less noise around AI, but maybe just a little different angle-wise. But what was sort of your takeaway? Was there anything that stood out to you? Anything that you thought that was particularly exciting or surprising even?
Yep. Well, I'm not one of the people that have been going to RSA for 20 years. So I've been going, I think, 6 or 7 years. And when I first started going as a product security and application security professional, there was hardly anything on application security, right? So that movement and that shift, before I left, our Forrester analyst sent us over a sort of a prep document, and it said that 20% of the vendors were related to app security, which means that instead of defending the environments, it used to be all identity access management and so on and so forth. Now it's also about that secure development process or managing the applications that you have running, in-house or in other formats. And so it was really, knowing that what was, it wasn't as much my world, even though I was in the CISO organization at that time when I went, and I was working a lot with those products. I come from a software development background. So now, I go there and I know, there were companies that were on the main floor that used to be in the startup floor that I've talked to over the years. And it's really exciting to see that growth of that, using the term shift left, like really what I consider, when I walked into the CISO's office 9 years ago to say, what are we doing to secure our development environments? What are we doing to help our developers? And seeing that movement toward that, because it's really such an important part, which is why, cryptography, but, a few years ago, 5, 6 years ago, it was only about signing or encryption at that level. And socket layers and such when it came to infrastructure and not really where things start. So I it's really seen a shift.
So you've seen that shift throughout the industry over the past, like you said, 6, 7 years that you've been going to RSA. And I think that's probably around the similar time frame that Schneider Electric had been running the crypto agility program. I think you mentioned for the past 5, 6, 7 years. So I'm curious to hear your perspective on some of the most significant lessons that you've learned throughout that time, and maybe how other organizations that are maybe just getting started can benefit from those experiences.
Yeah. Well, our crypto agility program started partially and mainly almost because we had a third-party crypto library set and wanted to be able to be more agile, thus the agility. And because in some cases, it could be replaced with more open source kind of standard, just say encryption models and everything. And so what we did is we asked all of our product teams to review, the ones that were working at that time with that third-party library, what their different options were. And it wasn't a straight, clear-cut, we can all use this. It required that analysis. So as part of that program, they really going into it, because when you're looking at operational technology, a lot of our products are multi-generational. So the code bases evolve, expand, there's adjustments, but, decisions that were made 10 years ago, are probably still going to stay there until then, until you must change or do something. So that program to discuss encryption and sort of all of that allowed us to be able to put that tenet forward about crypto agility and have experts in-house to discuss with those product teams, what is your model? What are you going to be looking at? Because at that time, it might not be because of how long ago it had been. The same person who made the decision before may not be on that team or around anymore. So you're re-examining it, which is great for architecture, right? and that usage of the term crypto agility, knowing that, are you going to be flexible when, as encryption changes? And again, operational technology, a majority of it is not internet facing, and it has a very different purpose. So it's a very kind of different, I would just say in general, when you're looking at the hardware side of encryption, because you also have to deal and manage through chips also for many cases. Like, how am I going to manage it? Because I have qualified these chips and I will only be able to handle these encryption models and methods. And if I want to move to this one, so some of them, there was extensive architecture rework and rethinking about how to manage that through that process. So it was good because it required a refresh in thinking that you don't normally have when you're just swapping out libraries. Yeah.
Like product version to the next product version,
Exactly.
kind of a change. Yeah. And it's also interesting, I think, because oftentimes, when we say crypto agility or cryptographic agility, we're immediately jumping towards, we have to be able to, replace one algorithm with the other. But it sounds like your main driver really was to have agility on the library level, to be able to switch out entire libraries on that layer.
Right.
So that of course is an entirely different approach to sort of that same agility or flexibility that you want to see in in those architectures. Now, did you call it crypto agility?
No. We used that term. Absolutely, that was part of the key points. But the program was not called the Crypto Agility Program. I can't share the name of the program, but but it was. And what you just said about the libraries, I mean, this is again, understanding that whatever method and technology was used, that was agile. So it's actually a dual agility, right? You have the technology used has to be agile, and the ability to make changes just in case it doesn't show agility, to be able to have that movement. So there were a couple of different layers to it.
Yeah. Well, be able to have that movement, like you said, all the way down to the hardware almost, right?
That's right.
So throughout that program, were there any, particular challenges or even surprises where you had an outcome that you just didn't expect, or,
Yeah. Some of them were tied to a root of trust that had to stay in existence. So, I mean, it's like, what are we going to do? We are really sort of, this is what we're married to. And I don't know the results of that, that one product, but, cause it went very much into the technical details, and a lot of, different pieces are involved in that. So it went way beyond just the global project structure. Some of the other things are, the open source versus commercial version, because some encryption models, are definitely available in both. And what is the support structure from a commercial standpoint was very important for certain products. And so not everything, could be managed through open source.
Yeah, I think there's a place for both, right? There's a place for open source, and there's a place for commercial available, for sure. Now, the other aspect that you have emphasized in conversations before, of course, is, for all these programs to even have a chance to be successful, you need C-level buy-in.
Yes.
Right, for all those initiatives. So maybe you can share, in this context of operational technology, how you approached in getting leadership on board, and also, looking at the cost and risk analysis that certainly was part of all of this.
Sure. Well, for the first part of it, the actual program was sponsored by the Chief Product Security Officer. So there you go, right there. And then the actual commitments to this were with the CTOs for the different businesses. So those, because this is much more of a, let's say, inside, back end, internals. So product owners don't they don't care, right? A product requirement is must have encryption and, must be able to do that. That's it. So it is a technical decision. So when it comes, from that, they understood, the reasons definitely, there was, it wasn't also that you have to have it done by end of year, which is not successful in any hardware affiliated world. We had a 5-year roadmap that we were working toward. And then from a return on investment or just a cost or anything like that, the commercial libraries and the different things, that is just something, you have to take in account. I can't go into a lot of detail. At a company in general, when it comes to cybersecurity, numbers don't always, are not the deciding factor, which, is good. What is the right situation from a threat landscape, from, how are we going to manage this? How are we going to maintain this product for the next 10 years because of our long product life cycles? All of that is considered and discussed as part of it. We've had, of course, other programs where you're able to say, here's the return on investment because of those changes. We didn't focus heavily on that aspect. And then if there was a commercial need from a specific product team, then they took ownership rather than being done at the global level.
Right. So then it was broken down to the specific product lines. And that makes sense. Now, given that you've run this program already for, like we said, 6 or 7 years ago when it started, was the sort of quantum related threats being on the horizon, was that already a driver back in the original program, when the original program started?
That's why we were leveraging the term crypto agility, is to say, you have to understand whatever you pick is not necessarily or can be the end choice. So if you're looking at a product that has a lifespan, of a shorter time, I mean, we've got 15,000 digital products. I don't know, from a firmware standpoint, how many exact versions that spread across our OT. But when you're looking at this from the horizon, you've got things that, hey, I've got a 4-year horizon. It'll still be there. But it's not something I need to worry about or be concerned about as much as something that this is a new product that we're in the middle of designing and want to go through. So we absolutely use the term, discuss the quantum aspects. We had some webinars and different things over the last many years before it became such a huge kind of conversation. We have, the person working on encryption also, was keeping aligned and making sure that they were aware of what was going on with the quantum development and such. And yes, and kept updated to make sure, to see and watch the work going on at NIST and other places. So that was part of it. And the CTOs, architects in the company, when you're talking to, I would say, really engineers at this level, we have just incredible engineers. The ones working with the encryption, they understood it. It's sort of like fun to imagine, right? So it was not a shock or anything that they weren't aware of. But now it's becoming national news. It wasn't, it was 6 years ago, so 7 years ago.
It was still very much in the realms of very obscure things that might happen.
Yeah.
And so I think, you mentioned lifespan, and you mentioned, products being in the field for a long time. Of course, if, we're talking about some of those OT systems that are there for literally decades, right?
Yes.
And you also said, a lot of them aren't even connected to the internet. So you won't have an IP address. Those are, offline devices in hard to reach places. So how do you, that obviously makes them very hard to update or, even prepare for those upcoming threats. So how do you address those challenges, and what are some strategies that are, effective in in mitigating risks around those devices.
Yeah. Well, in almost all cases, especially with hardware involved, you are not trying to change out that. Let's just say change the whole world for that one product line if you don't have to, right? So for those, I would say that since so little product gets patched from an encryption model. So let me step back a minute and talk about operational technology. So imagine a water treatment plant, and it has programmable logic controllers, PLCs, as we say. It has other products running things. It's got things that move, change chemicals, so on and so forth. And so this overall operational technology system, there's many different components to it. There's then software that helps monitor and look at all this and keep logs and data, just like you would for an IT system, but from a other kind of SCADA, or there's things called historians that hold that data. All of this that has been really in force and been digital since the 80s and 90s it has a specific function, right? It's got, here's my main job that I'm doing. That data flowing around, because of back then, it was all unencrypted anyway. So it's that it's sending this process information, one way, going down a one-way street, headed down, and then there would be commands. There are many different operational technology systems that are still using TLS 1.0, right? And or if they're newer versions, a new product that supports TLS 1.2 still has to be backwards compatible to TLS 1.1 and 1.0 and so on and so forth. So you have an environment that you don't want accessible for security reasons and critical infrastructure reasons and exposed. All right. So that's a lot of the operational technology, whether it's electrical utility, water treatment plant, a chemical manufacturer, just anything of that level. So when you're looking at changing out products and encryption, the encryption on those direct products may not necessarily provide, the overall system of, how are you going to defend and prevent living off the land? So segmentation and all that plays a key role. So when, so a lot of people do not update or patch their OT systems. It's a matter of, they may patch the software, but the actual physical devices, not. And they're like, it's running. We don't want to, modify it, or the integrator who first installed it no longer exists. So we know how to keep it running. And when that piece goes down, we replace it with the exact same model and so on. So the interoperability is highly important when you're doing upgrades for products. It has to be able to follow the same functions and work in the exact same way. So from an encryption standpoint, likely, let's say version 2 of that product versus version 3. Version 3 has, updated encryption capabilities in the firmware and has some additional features. They're not choosing to usually go to that. And if they do, your main focus is to keep the lights on, and literally keep the lights on in our world. So we don't see a lot of people updating OT to because of the encryption items. It's more about, can be more about, can it comply with regulations and rules about encryption? So it's more of a compliance area. It's of course a security area for sure. But yeah, so it would be very different than a firewall and router and the, what you have from an IT appliance versus the OT. Now, to go to your, to go a little bit past that is, when somebody does go in and let's say they have been breached at that facility or whatever. There is risk, but those are also usually unique equipment, and there are certain cases. The largest threats that are those when they're exposed to the internet, not necessarily when they've got, let's say, access to some other system within that same facility. Likely, unless they're intentionally trying to cause harm, are they not going to go through, go all the way through, to the various kill chains to get to that one piece. So encryption at that level, it's more about defense on the OT system itself. Now, when you're talking then about historians and definitely the operating platforms that operate those, where they're more software-based, encryption models and the threat modeling for that are highly important. So I just want to make the difference between OT devices in an operational technology world and the software.
Yeah, I think a lot of what you're describing really boils down to defense in-depth strategy. Yes. In architecting, designing, and then building those systems and running and operating them as well. And then I guess since you mentioned standards and compliance, and of course a lot of these things are driven by regulators. Yeah. So there's standards that are being discussed widely, like FIPS 140-3 or common criteria that have a slightly different angle of looking at the compliance. But especially in critical infrastructure systems, how do you balance between the need for regulatory compliance and the reality that you just described, right? I mean, there are going to be outdated systems, inevitably so. So how do you balance those competing requirements?
Yeah, so forward thinking from a product standpoint, future ready products. That's where taking in updated regulations or standards that are more general. Like I personally, and not speaking for the whole company because I've never seen every single contract, a lot of the utilities will mention FIPS 140, right? But a standard customer contract, they're not asking for it because it's not part of NERC SIP or something else like that. And so, when it is specifically asked for, like when you have to fill out NERC SIP 7 reports and so on and so forth, as part of procurement or as ongoing assessments, and just in case anybody's not aware, from a utility standpoint, they have their own regulations, and part of those regulations cover the products that they use. And so we provide that transparency of which products, and we'll specifically say these models are not, are at this level and this level, because we understand they will, especially if they want to create a homogeneous environment. Like, I've always bought this one product, and as long as you sell it, I'm going to stick with that, even though you're 3 generations past that. And so they acquire waivers because they have additional defense in depth and mitigations. So from a product standpoint, future ready, but being able to revise and update for regulations for existing products, especially when it's a device, takes a lot of time and requalification, a lot of safety testing, right? And not just cybersecurity and such. And so those are always considered at the product level to see, where it's required and such. So,
now you mentioned NERC SIP, of course, for some of our listeners who are not too versed with that environment. It's the National Electric Reliability Council Critical Infrastructure Protection. If I'm not.
Yes, something like that. And then there's FERC, which is the Federal Electrical Regulatory Commission. So FERC sort of and so NERC works with working groups that we can become involved in, whereas FERC is the actual regulatory arm. Yes. And it's an actual type of kind of regulation. They've got audits. So if they're a utility and asset owner, is running that utility or whatever, but it's mainly bulk electrical systems that it is over. And so there's audits that they have to go through, and it's quite involved. And there's different areas of that NERC, critical infrastructure protection that goes into grids and all sorts of things, grid management. So those are the other ones. I mainly know the NERC 7 and 13 because those are the product specific ones that I get asked about.
Right. And then they address generation, distribution networks, and
That's
that
right.
whole bulk of the power grid here in
That's right.
Of course, in speaking of the US here. So
Yeah.
well, that's great. Thanks for sharing all that, Cassie. This is exciting information there. So besides besides giving presentations at RSA and your day job, you do find the time to write a book. So you're the author of Software Supply Chain Security, securing the end-to-end supply chain for software, firmware, and hardware.
Yes.
So I think in that book again, you emphasize the importance of securing all the different layers of the software supply chain, right?
Right.
So I'd be curious to hear your take on the role of the supply chain security and how it's going to evolve in the age of quantum computing and the threats that come with it. So maybe there's some insights from your book that might be relevant for this whole conversation that you would like to share.
Right. Well, especially when it comes to quantum computing, I think that let's just say I see two types people in the world of supply chain. There are the ones that are thinking of the physical supply chain, like I want, to get my reading glasses manufactured, right? So you have just materials. And then in what is now we refer to as the software supply chain, you have, of course, you think about open source and commercial libraries and who worked on those. And that term wasn't around really until, it was around before SolarWinds, that event. But when I used it to someone, they're like, that's not a thing. I'm like, there's the supply chains, there's developers, there's all of us, and there's everything we work on. And that is a supply chain. What's really still not talked about, except for in the semiconductor world, is the hardware supply chain. And until, unfortunately, the attacks with the pagers, it wasn't, it was either chips or software. Like, there's lots of things that come out, right? My remote, it has digital components in it and such. And so I felt like I was talking to, the just empty air whenever I would mention hardware, bill of materials, and device security, and just the security of things and IoT. But now we have the U.S. Cyber Trust Mark. I worked with Singapore when they first did their cyber labeling. So there is that sense, and it's not just because of DDoS attacks on routers and bricking of things, but there's this whole sense that you need to think about the supply chain, especially the chips and the integrated components that you're selecting and qualifying. And as I talked a bit about, when it comes to hardware, I just can't pick any old chip off the shelf, right? I have a team, they check the specs, then they test against it. There's this whole cycle. You have to worry about interoperability, all of this. And that's the same from a standpoint when we're talking about encryption and where you're going. You're not just thinking about this one little device, but how does it interact in the whole picture? And so, when you're looking at, okay, if I, my threat model looked like this, if I used this chip and this, this encryption, and how is it going to work? Or this is what the vendor says the encryption, and are we going to be able to change out this chip in a future model that it might be compatible? Do we trust this vendor, supplier, manufacturer really, of that they would be able to update that? because you can't just like, oh, excuse me, can I just swap out your chip? I mean, we've seen that with laptops, right? Laptops just, they're susceptible. So that's all part of the supply chain that what we say is development, right? Shift left. We've got to shift that discussion, which was more just about import-export controls when it came to encryption. That also was affecting a development from an architecture standpoint, but the cyber aspects. And so I'm excited to see and eager to see more about this. And you mentioned the crypto bill of materials. I haven't had anybody personally ask me for crypto bill of materials. Should they be? Well, in my world, it's not probably the same as my friends at Cisco, right? So we do have edge-facing products and, physical products and software products. And so, the encryption and the crypto bill of materials, just like the AI software bill of materials, will be coming up. Yes, that I believe is the next wave. That's what I'm expecting to come about. I'm watching closely what's going on at NIST. But there is not, I would say, there's, like I mentioned in the book, I mean, I only had like a single line about crypto bill of materials when, one of my reviewers said, you should add this. No one's ever asked me for it. So I really want to see those things, at least get to a crawl stage. And I don't feel like they're there yet.
Yeah. And obviously, from experience that these monumental shifts take their time. Like you said, the program towards crypto agility was planned for a timeline of 5 years, not 1 year. So that's the acknowledgement that these things will take time, and won't just happen overnight. And like you said earlier, important to keep the interoperability in mind. There are legacy devices out there. It's not a rip and replace that will ever happen. Not in IT, I don't think, and certainly not in operations technology, even less so. Right. So there you have those, and I think you used the term future ready products. Right. So you have those brownfield environments and Greenfield environments where brownfield obviously is the already installed base, and then Greenfield are the net new systems. So are there any specific considerations that organizations must make when we're discussing migrating existing legacy OT systems versus building out new ones? And if you could tie that into the conversation around post-quantum.
Yeah, well, I think that overall, from a threat modeling standpoint, when they're designing the systems, I would say that there needs to be an increase in maturity when they're architecting systems to include cyber threat modeling, defense in depth, whether it be the Purdue model on OT. And as part of that, instead of just looking for vulnerabilities, they need to consider these topics like, quantum or, other areas. And if you are working with engineers, I've actually been working with NICET, which is a certification body that works with engineering. And we have this new certification called SSI, Software System Integrators. I might have reversed the word. Sorry, Michael, if I said it wrong. And this is really about bringing to other folks that are doing integrations and bringing systems together the knowledge of cybersecurity, not from only an application developer standpoint, not only from a network engineering standpoint, but from a overall comprehensive. You have to think about the big picture. The big picture is not just about your landscape today. It's like, what about your, when you're swapping out appliances or you're changing out SIM, monitoring, items, or if you are, in this case, thinking about encryption, because you can't just look at today's landscape. I mean, that's what modeling really means, rather than doing this. I mean, Miner's got a great ICS attack surface. I haven't reviewed it to see if it's got any quantum items on there, but maybe in the future it should. And of course, CWEs that are associated with quantum exist. So I think that we need to be looking at it. I would love to see more people, take this and put it in projects as sort of a requirement and do some pen testing specifically about encryption to see, where things have do not meet the current current needs, but also so that they can, plan for the future. Because that I would just heard, a NIST official talk about 2030, 2035. That's their date, right? I don't have a document to refer to, but he says that's what they're working toward. And so it could be next year, it could be 10 years down the road, but we have to be ready and understand it. And, this, I would say, just post-quantum, it's some of it's still just basic encryption. There are certain things that are just, from a basic standpoint, that should be encrypted. That still need to be gone to in the industry. Yeah, right. Or any system. I'm just saying in general, right? Yeah, when you're putting a new building in place and a new manufacturing floor, you've got OT and IT, and you need to think about it as a system and do everything that you need to do, and not just, that's the OT vendor integrating it, right?
Do the engineering salute, right? It's
yes,
it's that guy. Yeah,
that's that guy. That's right.
Yeah. And I think the timeline that you mentioned, of course, with a NIST saying that by 2030, RSA and ECC is considered deprecated, and by 2035, it's disallowed. Right? So you won't be able to sell anything into the federal environment if you're still using RSA and ECC.
Right.
So I think, speaking of encryption, I believe when we spoke earlier, you did mention that some of your systems are, consist of encrypted firmware that then even goes through certifications in the encrypted form.
Yes.
So how do you envision, that playing a critical role in securing OT systems and leveraging those quantum resistant algorithms in the not too distant future? Are you aware of any tests that are ongoing? Anything that you can?
Not that I'm aware of, and because of the complexity with being able to encrypt firmware and just has it exist, it's not really taken hold as a normal kind of custom model. I think in firmware, more where the focus is on the hardware trusted platform modules, and let's worry about things like that, getting some of those basics in for some certain technologies. So I don't see a shift or a discussion. I do know that there's and I have not attended it in the past, but in the San Jose or Santa Clara area, there's a hardware.io conference coming up in May. So I plan to sit in. It's very, very technical. I looked at the agenda, and I think I saw something quantum related on there, but that is something that really hardware engineers, especially hardware security folks, which is a blend, both IoT and OT, that needs to be considered more. So I recommend, anybody who's really interested in this topic, it shouldn't be such a small little group. I know the conference organizer for hardware.io, and he said it was initially, I believe, started because Google wanted, some focus on it. And so asked him to put this on, but it's a little known. It's a well-known secret, I guess, because nobody really knows about it. So I've been trying to talk about it to get more awareness out there, because and I didn't bring it up, but I have a good friend who works with the automotive industry, and I presented at an automotive cybersecurity conference. This is key. I mean, do we want our car that's rolling off the line in 2030 to still be able to run 20 years later? We do. And so you have to make those decisions about that now. And so for those long living products, again, software by itself, not, you can change things out, right? You've got that flexibility. When it comes to any relationship with hardware involved, you don't have that same flexibility. So, I probably will be driving an old Mustang, like my first car was, because I don't have to worry about sort of, encryption and different kinds of problems I may have, because upgrades would require changing out, actual buses and chipsets.
All of a sudden, classic cars have yet an entirely different appeal to them, right?
They do. They do. Absolutely. Doing the whole Mad Max thing beyond that. It's just the maintainability, which, when you think about from an encryption standpoint, that's what we're talking about. Like, what are we going to be able to do to secure those platforms?
Yeah. And of course, talking about hardware, I think early on you said one of the maybe more surprising outcomes of the cryptagility program were, finding a root of trust that was just that, a root of trust. Like,
right.
This is how basic it gets, right? Yeah. So that's probably also a good point to start for the post-quantum migration to go and address those basics first and say, okay, if we want to manage to be secure up the stack, well, maybe it's a good idea to consider starting at the bottom of the stack.
Right, right.
And I think,
which means that you should be asking your suppliers what their roadmaps are and their plans.
Yes. Yeah. I think that's a very good recommendation. Yeah. Talk to your suppliers, talk to your vendors, and make sure that they at least understand the question. Yes. Ideally have a good answer for it as well.
Yes.
Right?
Yeah.
And given, we're talking about timelines, it's 2025. How realistic do you feel for an OT environment? Is it that it's going to be 100% post-quantum in 10 years?
Yeah. There are still OT environments that have code that was compiled and put in place, from the 80s. So I think newer OT environments, it'll take quite a time. But the existing environments, modernization, it's not the key driver, for most of the reasons. There's products, I'm sure, that have admin or 1, 2, 3, 4 as passwords that are hard-coded in there. So there are probably likely more problems than lack of encryption or, encryption that has been is no longer secure. So it's one of the areas to consider, but it's not a 10-year item. So, however, when you're prioritizing, I mean, I definitely, if I ever needed a pacemaker or anything like that, I want to make sure that it has the right encryption and such and the right security, because that's an edge device, that could be manipulated externally. And so there's a bit of a difference depending on if it's an internet facing.
Yeah, that's probably the ultimate edge device is a pacemaker.
Yeah. Yes.
Yeah. So talking about timelines and sort of starting to wrap this up a little bit. I think organizations that are just now waking up and starting to consider that migration for the next 12 months, what's your recommendation? What should be, 3-4 areas of focus that they should consider?
Getting an inventory. That really helps. So that will be important. And I would say companies like financial institutions, things like that, they're great with doing those different kinds of inventories. others, especially non-critical infrastructure kind of manufacturers or just software publishers, they're not taking an inventory. These are all the different things, unless they do export compliance. So having that inventory of what's going on, being able to relay it and into a business sense, like this won't meet customer needs, this won't meet regulations, and then in a technical sense, this supports this kind of functionality or capability in the products. So there, it's a low risk versus medium or high risk. So prioritizing those that way as somebody is looking at their portfolio, and then from a overall, I don't think most companies have to have a special project or a program. I mean, it was from the volume of our size and other, large companies that I know, they do. But that's not necessarily, you can incorporate it with other pieces of updates, like if you're getting ready for the EU Cyber Resilience Act or, other kinds of regulations, you can include it as part of some of that. So those are the main two recommendations. If you are a creator of something, if you are a consumer, a purchaser or anything like that, understanding what your minimum baseline needs are. Not all of, you don't need, every single, from an encryption standpoint, you have to understand the use case and the profile of what you're putting in, because it's not all the same. Because I see, have seen contracts where it's all, must be encrypted, and it's just a general contract. I'm like, you're buying like about 16 different types of systems. So some of this is not really what you're looking for. I'm just like the word must have MFA. You can't, you're not MFAing that little PLC sensor on the line and it's going to Bob. So you have to think about it as OT systems or your environment and so on and so forth. So as a consumer, be aware. This is not something that I would say definitely your procurement group is not looking at. Your cybersecurity folks are probably thinking vulnerabilities and not PQC. So add that, it's a simple kind of question. If it's not, because it's never really in technical documentation, it'll say your encryption methods that you're using, but not what it's being used for, how it's being used, and so on. It's like having the AI logo on things. Like this is, RSA, whatever. But that's not enough detail. Yep.
Into context and
yes,
and really make sense of it. Yeah.
Yeah. Yep.
So, Cassie, this has been a great conversation. Thank you so much. And I think before we wrap up, maybe you can point our listeners to somewhere they can follow your work and stay updated on the latest and greatest.
Sure. Well, I'm on LinkedIn, so anybody can reach out to me, Cassie Crossley. My book is on Amazon, so again, you can just search for the author. I speak at different events, but I, would be happy to hear from folks around if they hear this, and we have great people around the world working on these kind of topics. So if there's a specific technical question, I know a few people, so I could probably figure out the answer. So I'd love to hear from folks.
Fantastic. Well, thank you, Cassie, for your time. I know we all have busy schedules, so appreciate you sharing all your insights. This has been a great conversation. Thank you.
Great. Thank you.
The quantum era is already here. With the right tools, the right knowledge, and the right mindset, together we can face it head on. To find out more about PQ Shield and how our cutting-edge solutions can help you secure your data against the quantum threat, visit pqshield.com. Make sure to search for Shielded, the last line of cyber defense, in Apple Podcasts, Spotify, or anywhere else you get your podcasts. Don't forget to click subscribe so you never miss an episode. On behalf of the team here at PQ Shield, thanks for listening.